drag this along here. And I plot the derivative as I drag this tangent changes and the derivative changes. It's exactly the same as what we started. So in our notes, if you have the graph of e to the x, the derivative is e to the x, which is going to cause all sorts of problems for your brain. Because it's going to say, what's the derivative? And you feel like you should do something, but the answer is exactly the same as what you started with. Feels kind of weird. So we'll look at some questions with this. What's the derivative of 5 e to the x? 5 e to the x. What if you had to work backwards? With a 4 e to the, if the derivative was 4 e to the x plus 15x to the 4, you would get 4 e to the x plus 3x to the 5, right? Because that 3x to the 5, the derivative of that, you see the 5 come out in front to make the 15. And then sometimes when they say these work backwards, we put a plus c, because technically there could have been any number there. And you didn't, if you just wrote this part, because the question said find a function, you would be right. But had you decided to write this, what's your favorite number?
17?
You could be like, I really like the number 17. So you could add 17 to this equation. Because what happens to the derivative of any constant? It becomes 0. So you're allowed to, if you're like doing a question like this and feeling like, I like to include my favorite number a little bit more, you can do that. You can have that plus 17 there, or whatever number. 17, good number. I like it.
Thank you.
Okay? So, the derivative of e to the x, the shortcut is that it's exactly the same. Doing it with the definition of the derivative is really quite complicated. Can you imagine? This is what, if y equal e to the x, you'd have to do the limit as h goes to 0 of e to the x plus h minus e to the x over h. And you have to come up with a way to cancel out that h. How would you do that with your algebra skills?
Log natural rules.
Right, well, yeah, you have to like figure out ways that you would go about that. It is not easy. Shortcut is super easy. It's just the same thing. So what we're going to do over the next little bit is learn a couple of shortcuts. Find the equation of the tangent y equals e to the x at the point 0, 1. Draw the graph of e to the x and the tangent line. So this is what we're looking for. I'm going to start with the graph.
Let me draw that.
There's my graph of e to the x. At 0, 1, I drew a tangent line. You don't know the equation yet. We still have to figure that out. But how do we find that equation of that line? Well, if you want to find an equation of a line, you need two things. You need its slope, and you need one point. We already have the point. The point is at 0, 1. How do we find the slope? And we're going to be doing a bunch of shortcuts with derivatives, enough of them that most of you at some time are going to forget the key idea of this unit, which is a derivative. All a derivative is an equation to find the slope of a tangent at any point. So if I need the slope, I need to find my derivative. And if I want to find the slope at a specific point when x is 0, I would need to plug in 0, and that tells me the slope. It was actually in that same exam, because we analyzed the whole exam of what students did well on and what they struggled with. One of the areas that they struggled with is some of them on the exam forgot that all a derivative is is the slope of a tangent line at a specific point. And since you learned slopes in like grade 10, it seems kind of, I have to admit, when I learned calculus, like, this is just slope? There's like calculus gets hyped up, right? Ooh, I'm taking calculus in high school. Like all of these other courses were like pre-calculus, learned all this complicated math just to do slopes? There's like a level of anticipation. You know when you anticipate something too much? And then it's like sometimes you get disappointed. Online dating for 3 months and then you meet the person and you're like, oh no. The disappointment is there. No. Okay. So we've got our slope, we've got our point. Now you can either use y equals mx plus b or y minus, I'm using here, remember this one, y minus y1 equals mx minus x1. Whichever formula you choose to use, you can just rearrange this formula and you're going to get y equals x plus 1. If I had used y equals mx plus b, a lot of people like using y equals mx plus b because they remember it. I know the slope, so where the m is, I could plug in 1. I know the point, so where the point is, when x is 0, y is 1. And then from this, you could solve for b. Once you've solved for b, you could write your equation. That is also perfectly fine.
Okay, what is B?
B is your y-intercept.
Oh, okay.
So now going back to our GeoGebra app that we had there, e to the x, I'm going to play around with this equation. Instead of doing e to the x, this time I'm going to change it to 2 to the x. Push enter, clear things out. It looks like an exponential function as well, right? But it doesn't quite match.
Yes.
What happens if I had 5 to the x?
Just be like taller.
Oh my goodness. Shouldn't have the point away. I shouldn't. Oh, there it is. There we go. I know what I have to do next. Oh, I'm still using pi on the scale there. Oh, yeah. Oh,
Small.
it's a little bit above. You notice 2 to the x was a little bit below. If you use e, it's perfect. So it looks like if you have anything other than e to the x, it's close. So we're going to figure out what the derivative of 5 to the x is. So first of all, I'm going to cheat and show you the formula. If y equals b to the x, then the derivative is just like e to the x. It stays the same, but then you have to add a little thing to compensate. A 5 to the x. And the reason for this is as follows. I'm going to play around with this a little bit. If I had 5 to the x, could I take the 5 and rewrite it like that? In other words, this would have to equal this. Is there a way to do that? And the answer is yes. How would you solve this part of the equation? You'd use natural logs, right? So if I took the natural log of both sides, I would get that the natural log of 5 has to equal k. So that means that 5 to the x is equal e to the natural log of 5 to the x. And normally the derivative of e to the x is itself. So the derivative of 5 to the x has a little bit of that itself, but because there's this extra natural log involved, that shows up. And once we learn a couple more derivative shortcuts, it shows up as a multiplication there in the end. Okay? Why does it show up as a multiplication there in the end? Well, you can use your log laws to play around with this. Okay, yeah, let's see. Well, no, I'll leave it for now. We have to learn a few more derivative shortcuts, and then this will make a lot of sense. But for right now, we've got this as our new shortcut. If you have any power other than e, it also stays the same, but you have to also multiply it by the natural log of that. So when we look at an example here, 3 to the x plus 5x squared. The derivative of 3 to the x will be 3 to the x times the natural log of 3. And then this one is 10 to the x. Because you bring the 2 out in front, subtract 1 from the exponent. So again, once you know the shortcut, then your life becomes a lot easier. Next shortcut. Again, I'll show this to you with a graph. Here is the natural log of x, and if I took this and dragged it along here, I get this graph. Do you see that the blue graph looks like it has an asymptote vertically and an asymptote horizontally? It does. Do you recognize this graph? It's half of a graph that you know. If you cheated and read ahead in your notes, you see the answer. The derivative of the natural log
1 over x, probably.
is 1 over x. Can you see that being half of your 1 over x graph? That's why this part here, because natural log of x, you're not allowed to take the natural log of a negative number. So when you do the derivative, it's only that part of the x greater than 0 for the derivative as well. So if the derivative of natural log of x is 1 over x, and you have a 5 in front, does it make sense that that would be 5 times 1 over x?
5 over x.
Or you could write that as 5 over x or 5x to the minus 1. Okay? I'm going to stop. I'm going to make that one video. Here we go.